A very good afternoon to one and all present here. I, Drishti Lalwani, feel privileged to welcome you all on the behalf of AITR ACM Student Chapter to this insightful event on Internet of Things. Before we get started with our event, I would like to brief you all about IoT. The Internet of Things describes the network of physical objects that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the Internet. Over the past few years, IoT has become one of the most important technologies of the 21st century. Now that we can connect everyday devices to the internet via embedded systems, seamless communication is possible between people, processes, and things. Today, we have an industry expert, Mr. Lokesh Bhatter, as a guest speaker for our evening. Now, I would like to invite Diksha Chagani for introducing the speaker.
Thank you, Drishti. I'm profusely overjoyed to introduce Mr. Lokesh Bhatter. Mr. Bhatter is working as an engineer manager in data platform organization within John Deere. He is responsible for enabling near real-time features for John Deere customers. He started his career in 2000 after completing his master's from Sri Vaishnav Institute of Management, Indore. He worked for a couple of offshore development centers in Indore before moving to the US in 2003, where he consulted different companies before joining John Deere. He has been with John Deere for more than 14 years, where he joined as a technical lead, later on moved to technical architect, product lead, and now group engineering manager. So now, without any further ado, I would like to invite Mr. Lokesh Bhatter. It's our honor to have you here, sir. Over to you.
Well, thanks a lot for this nice introduction. I'm really happy to be here. So let me get started. Let me try to see if I can present a window. Let's see. Okay. It's like there's some, I have to give some permissions to Google. Let me do that real quick and we can get started. Accessibility, camera. Services.
So you have all the permissions now.
Okay. Yeah, I think I have to give something on my MacBook also. For this access. So I'm just looking into that. I think we should have done this earlier. Okay, screen recording. There you go. Okay. Google Chrome. Okay, I might have to disconnect for just a second. Please bear with me. Just 1 second. Are you guys able to see my screen? Are you guys able to hear me okay?
Yes, sir.
Awesome. So which screen are you seeing? Are you seeing a big screen with IoT and precision agriculture? Or are you
Yes.
seeing this? Okay, great. Okay, so let's get started. So first of all, thanks a lot for having me here. I'm really excited to talk to students from my hometown where I grew up and studied. So it's really exciting. And thanks a lot again for such a nice introduction. So today we'll be talking about, I think Drishti has summarized very well the definition of Internet of Things. We'll just go over what it really is, and how Jowdy is using and that sort of stuff. It won't be too technical because I wasn't sure what all things have been covered. But what I would say is, ask questions, and if you want to drill deep onto something, we can probably go deeper whenever you want. Okay. Uh, and one of the things I want to just highlight here is, I want this to be an interactive session. So please ask questions. Asking questions is the best way to learn, because I'll be covering at a very high level. So if you are interested in a specific area, feel free to ask questions. You can submit questions in the chat or send your question to the moderator, and I can answer it that way. And I'll also try to take a pause.
Sorry to interrupt you, sir. Please zoom in
Sorry.
your screen. Please zoom in your screen.
Uh,
The
you.
students are not able to see.
So
Could
it
you
is in
please
a full.
actually it is not properly seen like
So
visible
actually,
on
you have screenshot your screen share.
Okay. So let me try this again. Set up the. I think slideshow is okay. So are you
So just
still
share
seeing
the
my main screen,
slideshow.
right?
So
Let
Sir,
me
last
I
time
see.
I
guess your
shared the presenter view.
presenter's view is being shared from your PowerPoint.
Okay, got it. So that's what I just wanted to confirm before I start. So let
Yeah, so
me
like if you can just
open the. So I'm just sharing this screen. Now, which screen are you seeing? Are you seeing with the presenter view or are you seeing the main view? Hello?
So slideshow.
Okay, you're not seeing the presenter view now, right?
Yes,
Yes,
sir.
sir.
Okay. So, and is it nice and viewable now?
Yes, sir.
Okay, awesome. So let's go over the agenda. We'll be talking about John Deere first, just to give you the context of what John Deere is. Then we'll be covering Internet of Things, and we'll be putting the Internet of Things in the context of farmers, right? Because this is what kind of John Deere do, help the farmers, and of course there are other areas of John Deere as well, which I'll cover. But I just wanted to kind of give you guys an area context where we can just start kind of drilling down and figuring out like how IoT is helping. We'll talk about precision agriculture, and then we'll start getting a little bit technical, where I'm going to talk about what are like the tenets of like John Deere IoT Foundation. What are the different things that enable John Deere IoT, and what does the data platform do? Okay, to help you understand the whole big picture. Okay? So first, let's talk about John Deere. So John Deere is an equipment manufacturing and distribution company that works in agriculture, as I mentioned, primarily, but it has a lot of big footprint on construction, forestry, turf care segments. It is rated as world's largest manufacturer of agriculture equipment, with locations around 70 countries and close to 70,000 employees, and a revenue of $44 billion. This company was founded around 180 years ago by a blacksmith and manufacturer named John Deere. And the thing is, his first product was a plow, right? The one that farmers used to work on their fields, right? So what he did was, earlier the plows had a problem where the mud used to stick when they try to break the ground. where he designed a self-scouring plow where it used to clean itself. So this is where the humble beginnings of John Deere. And in India, actually, we have factories in Punjab, Pune, and right in our backyard in Devas. So if you see any green tractor, you probably want to look at closely. It might be John Deere. So now let's talk about IoT. I think Drishti has done an excellent job of covering that. And because this was the only simplest definition I found, there's a lot of definitions and kind of having a lot of jargons and buzzwords. But I think this was the one that I found, and looks like Drishti also found the same thing. So I'm glad she covered that a little bit. So let's zoom into what this really means. This seems like a paragraph saying something, but let's zoom into what this really means. So I'd like to focus, grab your focus and put it into like three major things. Number one, it says it is a network of physical objects. Physical objects could be anything, right? It could be like your smartwatch that you're wearing, or a complex John Deere machine. Like it's a thing, right? It's a physical object. And the second thing it mentions is it should be embedded with sensors and software, right? What I mean by that is it needs to figure out, it needs to sense its surroundings, and it needs to measure something. It might have some sort of software to convert the data that it's collecting into information. It could be as simple as a smart switch, right? Which just maintains two states, whether I'm on or whether I'm off, right? Just two states. Or it could be, again, a very complex machine like any John Deere machine or any other machine that's actually capturing different measurements. It's capturing what's my engine speed right now, what's the fuel level right now, how fast I am going, what I'm doing right now. All of these are measurements, and these are captured by the sensors. There has to be sensors, and there has to be software running that's making sense of those sensors. And third, an important thing is the network, because if this information, all this data cannot be shared, then it does not truly open up the potential of that particular thing or Internet of Things. So once this data is shared, that's when it open up so many possibilities of using that data for different purposes, right? Like example, your switch is on and off. Like what good does it do, right? Nothing. But if you can share that information with some other device, right? Uh, like for example, if you're entering into a house, right, and if the switch is off and it knows that I'm right now off, and the sensor tells you, hey, someone is coming inside, it might turn the switch on, lights will be on, right? So that means these two devices are exchanging some information or data with each other over a network, and that's what the power of Internet of Things comes. And there are different types of IoT, like there's industrial IoT, consumer IoT, but for the scope of this talk, we'll be focusing about agriculture and how IoT is revolutionizing agriculture today. Okay. So I'd like to pause for a minute and just see if there are any questions. No? If none, let's move on to the next one. Why would farmer need IoT, right? Our more urban thought process is, farmer puts seeds into the ground, give the water, fertilizer, and when the crop is mature, just harvest it, right? It's a simple process that existed for thousands of years, right? So why do we need to put all this technology? Why do you want to shove this technology into a simple process as farming? And we have been surviving that for thousands of years. Why do we need to do that, right? Anyone want to take a guess why that might be the case? Nothing? Okay. Okay. So one interesting fact is we are today 7 billion people, and we will grow close to 10 billion by 2015 in just 28 years, right? That means we need to figure out a way to meet the demand for more food, feed, and fuel, right? Because why I say fuel and feed is, today a lot of crops are being used as a fuel. Like corn can be converted into ethanol that gets into your petrol, and that powers your vehicles, right? feed for animal feed and all that. So we have to meet for these many peoples, that much demand will grow. So how do we basically do that, right? Of course, the answer is we produce more food, we produce more crop, right? Great point. But how? Because the land is limited. Last I checked, earth is not growing, right? Just like our population. So earth is limited, right? The land where we can farm is limited, right? Then how do we produce more with the same amount of land? And this is where the technology comes in, right? The answer is technology, right? You might be thinking like, well, yeah, technology, but how? Like, especially in context of our talk, which is IoT. How come Internet of Things can help produce more food, right? So the answer is by using the farming practices that uses technology to ensure the crop and the soil gets exactly what they need for optimum health and productivity. And this is what is called as precision farming. It's all about getting the maximum output with the limited amount of resources, placing the seeds at the right spacing, at the right depth, giving it the right nutrients, giving it the water exactly what it needs, not more nor less, and harvesting in a sustainable way. And this is where John Deere's equipment come to help. Okay, let's see how agriculture has changed. On your left, you would see a traditional tractor like this was in 1939. It's a John Deere Model B with no electronics. You have to start with your hand. It has 16 horsepower. Even in India, you'll see a lot of tractors like this. A pretty basic tractor. Now compare that with the tractor on the right. It is the state-of-the-art latest John Deere 9RX tractor. It has around 620 horsepower. Compare that with 16 horsepower, right? Including a very nice big display, which we call it as command center display, that can help you control any part of the machine. It can self-drive. We bought this technology more than a decade back when Teslas and those were not even a thing, right? Of course, we run it on the field, and I'm going to cover what that really helps, how that actually helps. It has in the cab, it has a nice refrigerator. It has a very nice sound system, because farmers here, when they work, they have to work like 14 to 16 hours a day. They have to put in that much time because a window is very narrow for harvesting, for planting seeds and that kind of stuff, right? And and of course, it is an IoT capable machine. The whole thing, this whole huge thing is an IoT, right? So the what essentially what's happening is the machine have more technology today than ever, and this is actually helps. If you see, like, there's communication technology, there are digital tools, this captures the real-time data, it has a lot of sensors in it, right? And then in order to really understand the benefit of why this technology and how this technology helps, first let's look how we traditionally farm, right? In most of the places around the world, yeah, we kind of plant the seeds into the ground. Sometimes we use a tractor, right? And on the right hand side of this image, you can see the plants grow, right? So nice, very humble beginnings. That's how we used to farm. That's how we used to feed the world. But now this particular way is not that effective, and this is where we used to traditionally farm. Now let's talk about precision agriculture, right? And look at this image and contrast this image with this previous image, right? Look at the right side, how plants are emerging, and now look at this one. You see a nicely planted rows, very dense, very close to each other, right? And they are not there for aesthetic reasons. It does not like, oh, because they look really good, we want to plant it this way. No, it's not like that. They are planted to take less space, right? The space that's exactly needed to get the maximum productivity, to get the maximum sunlight and nutrients, and in turn produce more crop with the same size of land, right? Now, if you compare this with the traditional farming, right? So think about a case where, for example, you are growing corn, right? Bhutte, what we have in traditional farming, because you cannot control where you are going to put the seeds. You might put some seeds, say 10 inches apart. Sometimes you might put some seed that is 1 inch apart, right? So the cases where the seeds are too close, they'll be compete for the resources. If you put a fertilizer or water in it, they are going to compete for that. So that means neither of them will be healthy, right? And if you are putting too far apart, you are wasting a lot of space, right? An example, a typical corn. I'm just taking corn as an example so that we can stick to one crop and so that you can start to understand. Uh, we can plant the corn at like 2 to 3 inches apart. Usually, that's based on the seed. That's what the optimum this thing is. What to say, like spacing is, right? Now the thing is, if you can plant like that, that means you will be able to get more seeds into the ground. That means more crop, more productivity. Like, let's try to put this into a context. An average US farm is around 500 acres, right? An average farm. But there are many large corporations that have hundreds of thousands, like lakhs and lakhs of acres in their farm. Now let's think, if we do traditional farming, in an acre, for example, if you're in traditional farming, you are putting 600 seeds. Whereas if you do the right spacing, if you can control that, you can put, say, 1,000 seeds, right? And now you just multiply that with 500 acres or thousands of acres. Even with 500 acres, you are kind of putting 2 lakh less seeds into the ground, close to, right? And that means if each plant can produce 2 to 4 ears of corn, you can just start seeing how that comes into and like start impacting the whole productivity. If you put 2 lakh less seeds, 2 lakh less plants, that means 4 to 6 lakhs less corn, right? So within just 500 acres. So if you're able to put that, that's where you kind of start getting more productivity, right? For example, this is an exact emerge planter from John Deere. So it actually puts the seeds at precisely the same spacing that we have, like with whatever we said. If we said like 2 to 3 inches, it's going to put each and every seed just 2 to 3 inches. If you put like 2 inches deep, it's going to put exactly 2 inches deep, right? So it can actually plant 30 corn seeds per second. Now just think about it. Like with 500-acre farm or 1,000-acre farm, it's putting at 330 corns per second. We can achieve a lot within a less amount of time. This is another example, right? During growing season, this particular is called as an applicator. It's a sprayer. And what it does is it actually put the pesticides or herbicides onto the plants. And what this particular thing does is it's called a see and spray technology. So as the tractor moves or as the sprayer moves through the field, there are cameras mounted on this hull, and it actually looks at the plant and the weed. It detects which one is plant and which one is weed, adjusts the boom, adjusts the spray nozzle, and directly spray on that particular weed, right? And all of this happens within 200 milliseconds, right? Just think of that. Like you are just moving, and it was just detecting which one is plant, which one is weed, just shooting it and just killing that. I'm just kind of trying to move a little fast because I know it's kind of we are close to, we have less time. But again, we can, if you have any questions, feel free to interrupt. So these are the tenets of the precision farming, right? We had to prepare the soil precisely. Don't waste the seeds, right? Plant the seeds at the right distance and the depth so that they get a chance to grow as a healthy plant. Make sure you provide the right amount of herbicides and fertilizer to save earth, because these pesticides are pretty toxic, right? And give plant exactly what it needs when it's time for harvesting, and make sure that you harvest every grain possible, right? So now you probably start thinking like, wow, so that means it's a lot of data that we had to capture, right? Because if you're counting every seed, now, yes, we collect a ton of data. We collect all of this data, where each seed is planted, right? So that means it's a huge amount of data that we have to collect and send it over cloud. This is where IoT comes into picture, because in the definition, if you remember, I mentioned there has to be sensors and softwares that running that should be running on the device. In our case, it's an equipment, right? So we have a fleet of around 500,000 equipments across the world, right? And out of them, more to like 350,000, 100,000, like 3.5 lakh or 350 lakhs devices call in every single day. They call in around 1 crore times every single day, because as soon as they get in the cellular coverage, they call in and they stay connected. They might get out of cellular coverage, they might disconnect. So they call in like around 1 crore times every day, and they are sent around 5 crore messages every single day. And the peak time, it can go to 7 to 8 crore messages, right? When I say messages, it's all the data that they are capturing. So now, on an average, we process around 95 terabytes of data. It passes through our data platform, like what we process. So put that into a context. It's around 47,500 hours of high definition video, or 2 crores 37 lakhs 50,000 high definition pictures, right? So you can try to understand, like, now the amount of data, the thing that we are kind of trying to process with these huge machines, with the huge amount of data, and IoT is the whole backbone that powers all of that, right? So we have this, IoT, a combination of sensors, the software that runs on these machines. There are millions of lines of code that runs on this machine, believe it or not, right? So when I talked about auto track, right, like automatic self-driving tractor, so that self-driving tractor is, works with a combination of multiple, hardware sensors, GPS, and all that. And there is a lot of code that makes sure that I'm staying on track, I'm not moving, because these are like heavy, huge machines. How do we make sure that they stay on track, right? All of that is done by software, and all the data that is being sent on the cloud. There's again millions of lines of code that processes all of this data. A lot of employees, a lot of organizations trying to get this data and help customers. So again, I'd like to take a pause and see if there are any questions. Wow, you guys are a pretty quiet group today. I'm assuming that probably this is making sense, or if it is getting too complicated, let me know. I can simplify, or if you guys want to know more, let me know. Okay, so basically, as part of our IoT, these are the different stacks that we have, right? At the bottom level, we have the hardware and the devices. These are the things that are there on the machines that that basically sense their surroundings and capture the measurements. Then we have this job automation software, right? This is on the machine, like it works with the combination of the hardware and devices, and it's doing the job. Like I gave an example of our see and spray technology, right? So the camera is getting images. There is a software that compares those images with and figures out whether it's a weed or it's a plant. Then it tells the sprayer to, like, okay, at this time just spray that, right? So all of that is job automation software. And then we have connectivity. So the data that we are capturing, right? What's the engine RPM right now? What's the oil pressure right now? What's the fuel tank? What's the fuel level right now? What am I doing right now? How much planting I have done so far? All of that. The data needs to be shipped to cloud, and connectivity is an important part of doing that. And then this data goes to another layer, which is where I personally work, which is data platform. This is where we kind of receive the data, we process the data, we make the data usable for our application, for the front end application and analytics. Okay. So let's focus on kind of the basic tenets of or what's how our IoT works, right? So these are the hardware and devices that are on the machine. These are the foundational or building blocks that powers John Deere's IoT system. On the leftmost, here, you would see what we call it as displays. So think of it as like a dashboard, a nice big dashboard that visually shows you what's happening in the field, or what's happening with the machine. So for example, if it is harvesting any seeds, harvesting the crop, what is the grain quality? There's a camera that you can see on this display, and it will tell you what each function or which part of the equipment is doing, right? Next is the GPS receiver. You might see this seems to be a little bigger than your GPS chip on your phone, right? But the thing is, the reason for why this is that big is the precision that it works on, right? Our GPS on our phone is like they can be many feet apart, accurate as far as accuracy is concerned, right? But in this case, these GPS are accurate to less than an inch. Now think about, right? Only this much in the entire planet. It also accounts for the tectonic place shifts and shifts and everything. Think about that. It has to be that precise, because as you have seen those rows, big rows of all the plants, it has to precisely put the rows right there. So for that, it needs to know the right location. And this is the receiver that actually, enables that. This also enables all our automatic, self-driving tractor also, because we don't want to crush all the plants that we have planted when we are doing a spraying operation, right? So this helps to keep the tires right between the rows and not on the plants. So because for all of these functions, it is imperative that we need the exact coordinates or exact location that's accurate to an inch. Then we have cameras and sensors. As I talked about, these are the cameras that used to do job automation, and capture a lot of data. And then we have compute and control, where our gateways that send all this data through cellular and satellite to our cloud. Right? We use Amazon Web Services IoT platform that is based on MQTT protocol. So this telematic device basically connects to cloud, and then that's where it kind of pushes the data over there. So this is like a very simplistic definition. Like if you look at this 10,000 feet view, this is how it looks like. So we have equipment.
Sorry to interrupt, sir. There is a question from the audience.
Sure. Yeah.
Good afternoon, sir. Am I audible, sir?
Yes, you are.
Sir, so this is Abhay. There is around 80% of small and marginal farmers in India, and the cost effectiveness is always a point in farming for such farmers. So, how the hardware cost is going to be taken by farmer? Is there any subsidy for the users? And another thing is that poor internet connectivity in rural areas are mostly, so cloud connectivity may be an issue for them.
Good. Very, very good point. So this is kind of a continuous challenge, because at least in US also, farmers are comparatively better off. The rural connectivity is kind of comparatively better, but still, when we talk about, I'm just going to take an example of South America, Brazil, where we have the similar kind of problems. But the thing is, at least in Brazil and US, the things that goes in their favor is huge fields, right? They are very big fields compared to India. So I'm gonna towards the end, I'm gonna talk about what we are trying to do for Indian market. But you are absolutely right. These are the connectivity is a major problem that we face, and we are heavily investing in some of the LoRaWAN or those kind of technologies, and kind of putting the towers into the rural areas. And another thing that we are working on is enabling our satellites more. So we have a contract with Iridium network of satellites, and we are kind of John Deere is exploring to put their own satellites into the orbit, so that we can kind of transmit this data through satellites to our data centers. Again, that is still work in progress. It might take some time to do that, because we are still kind of we're working on that. But at the end of the day, these are the things that we are kind of trying to do in order to help the farmers across the world. Does that answer your question? Is that a yes, or do you have any follow-up question on that?
Yes, sir. Thank you so much.
Okay. Uh, okay. So again, great question. Hardware is definitely a thing, and I'm going to cover later on like how we are trying to address that. But especially all this sophisticated technology makes a lot of sense for bigger farmers, where we had to do a lot of things within a narrow window, but not so much for smaller farms. And see, at the end of the day, what happens is once this technology is introduced, there are like early adopters, right, who take the majority of the cost. And as the time passes, the technology kind of start getting cheaper and cheaper, right? So you think about uh, the cellular phone, right? In the beginning, when the cellular phone came, compared to landline, they were so expensive. The plans and everything was so expensive. But as the early adopters took that cost, and slowly it started becoming cheaper. And now if you see, internet is so cheap on phone, and even phones are so cheap, right? So we hope to kind of have the same kind of thing happen to our agriculture also, because more and more, if you are able to justify the, the cost of the equipment by the increase in the productivity, that could be one way to go for it. Another way to go for at least the pattern that we are seeing in US is what happens. There are a lot of companies that are coming up that own a fleet of these big machines, right? And if you are a farmer, and I'm a kind of a contractor, I would say, I'll say like, hey, you know what? I will go and plant your seeds, right? And I'll take the contract with your neighbor, and I'll take the contract with his neighbor also. So that way, now I have like 4, 5, 6, 7 farms that I can go and plant in one shot. So there's another model that might work back in India also. It works in US. Also, like, I'm a contractor. I'll take a contract from all these fields in this area, and I'll just go ahead and plant it for them, right? And putting seeds is not a big deal. There are big seed tanks. You can put seeds, and same thing for harvesting and all that. So we have big companies that have fleet of 300, 400 machines that just start from south and go up to north, or go up from start from north, go up to south, and do all of that. So that could be another thing that we can do. Again, coming back to this, so this is, as I said, this is a very high level diagram of how this our IoT works, right? So the data is regularly captured from the machines, and as soon as they have the cellular or satellite coverage, we get the data. We have global contract with AT&T, so we use AT&T to kind of ship all the data to our AWS IoT cloud. Just a second, I think are you guys able to hear me okay still?
Yes, sir.
Okay. So Aryan, how are we doing on time? We should have 10, 15 minutes left, right?
Yes, sir, we can do that. About like 20, 25 minutes.
Okay, great. Yeah, I think I should be done in 5, 10 minutes now. So yeah, so basically, all the data is shipped into to cloud with using AT&T and satellite. And then what we do is, once we receive the data through AWS IoT, all the data is sent through data platform. And I'll go over data platform and like zoom into data platform in the next slide. But I'm just kind of trying to show you the flow of data. So data comes from the machines to IoT. It goes to data platform, where we kind of process this data. We receive the data, unpack it, decrypt it, because all this data is encrypted end to end. We decrypt it, unpack it, kind of model it, process it, and then we enable. We have APIs that can power our flagship product we call as Operation Center. It's basically a front end to the data that we receive. So this is where we have nice maps, which will show you where your machine is right now, what it's doing, and all the productivity and everything. And then this data is also kind of sent to analytics warehouse, where this data is analyzed both from the customer side and from the engineering side also, right? So there's different models that the data scientists work on that will predict when the machine is going to fail, right? Because a machine failing in the field during the season is very expensive. A downtime is something that the farmers cannot afford, at least in US, because the window is so small, right? So we use this data to figure out when the machine is going to break, or we just proactively tell, like, hey, looking at this all the data that we are receiving, there's a probability that your machine will break in a day or couple days or even hours, right? So all this data that come through, we had to process all of this and to trying to figure out all of this predictive analysis. And there are like different teams working on different kind of analytics. Some teams work on figuring out maximizing the productivity for our customers. Like, hey, we have seen that you have placed your seeds like this, but because you have elevation in your field, that's where this particular area was not able to produce more crop. And then they can help them out, saying like, okay, if you do it this way, that way you can have more productivity. So there are a lot of data science models that continuously run and trying to learn and try to suggest, recommend to our customers. So this is how overall the data is flown. And this is kind of a zoom in of how our data platform works. So our data platform is broken down into these 4 phases, right? One is the ingestion phase. So as the data comes, the very first thing that we do is kind of store this data, right? The analogy that we want to take here is the data that comes, it has a lot of junk in it. So every phase kind of slowly clears that data. And if you see here, the kind of the water is very muddy on the left, and then slowly it kind of get purified. And towards the end is what we have the final product, right? So the first thing what we do is, as soon as the data comes, we provide the durability guarantee, right? So once the data is stored durably on our servers, that's where we tell the telematic device, like, okay, I got this data, you can go ahead and delete it. Because the devices or the computers on these machines, they don't have this terabytes and terabytes of space, right? Our cloud has, but they don't have. So we had to let them know, like, hey, we got this data, you can go ahead and delete if you want, right? And then that's where the device can kind of clean up that space and kind of start collecting more and more data. Once we ingest the data, the next thing what we do is we model that data. So as you might assume, there are lots and lots of different data points coming. They come from sprayers, they come from planters, they come from tractors. So we had to model the data based on what equipment it is, what it was doing, and that sort of stuff, right? So it could be machine data, it could be agronomic data. So we just kind of model the data into the right data models. After that, the data is moved to enhance phase.
Sir, you are not audible.
Okay, just a second, let me. Are you guys able to hear me okay now?
Yes, sir.
Yes.
Okay, great. So let's get back to our presentation.
Sir, I also have a question.
Uh-huh.
Sir, I also have a question.
Sure. Yeah.
Sir, I get that why we are studying this, but how to increase awareness in India? Like many farmers are still using traditional practices for farming, irrespective of the requirements. So, how to increase the awareness in India?
That's a good question. So the thing is, first of all, we have to show them what precision farming can do for you, right? And second thing is, we have to bring the cost down, because everywhere farmers
are kind of very cost conscious. Like they try to figure out like how much cost per acre do I have to incur, right? So only way is kind of showcasing like, hey, we are able to produce this much with these kind of farming technologies. It's all about kind of raising the awareness, means like someone has to take a lead, right? And it has to be a partnership between the company, the government, and the local authorities to bring this awareness to the farmers out there, right? It could be by means of some campaign that the companies can run, like, hey, with our tractors or with our equipment, you can do this, or you can just with the help of government, they can give some subsidies to kind of bring that cost down a little bit. And it has to be a mutual partnership. And of course, from company standpoint, they had to do their part by bringing the cost down. From government side, they had to do their part of providing subsidies and kind of spreading the word, if you will. And the local authorities also need to kind of participate and going door to door, helping the customers or farmers understand the value of precision farming. Does that answer your question?
Yes, sir. Yes, sir. Thank you, sir.
Great. Yeah, you're welcome. Okay, let me try this. Okay. Which window are you guys seeing? The presentation or the presenter?
Sir, the
The presentation.
presentation.
Okay, great. Okay. So yeah, so we talked about model, right? So we got the data in just stores the raw data. In the model, we just decrypt that data, open the data, and then put into the right data model. The next phase, what we do is we put some context information, right? So for example, when I planted this particular geographic area, what was the weather at that time? What is kind of the soil type of this? Because that's a master data, right? A weather data, it can be captured by sensors, but it can be captured from somewhere else as well. So we kind of put all this contextual information, which organization this data belongs to, like which farmer this data belongs to, right? What's the soil type, etc. So we enhance that data with some contextual information. And then at the last stage, we just transform this data. So for example, you want to figure out, you have to have a map of how seeds were planted, right? So where I was not able to plant seeds properly, or where there was some problem in the field. So if you see this map, this map, so there are some green and there are some yellows and there are some reds, so this is the transformation layer where we actually create specific map layer, what we want to call it as, where we are going to show you exactly at this location is where the problem is. So then the farmer has some pointers to go and figure out, like, hey, why is this? Why do I have less yield here, for example, right? I planted the seeds properly over there. What happened in here? So they might go and figure out, oh well, there was either an elevation, or there was a ditch out there, or there was some manifestation of some pests and that sort of stuff. So they can kind of get it fixed. So transform layer is the last layer that actually creates different views of the data that we have processed. And again, this whole thing is kind of is used for both the front end application and also for the back end data science. When data science would see, when they analyze this data, they'll see like, well, last 2 years I've seen this particular area of field is producing a lot more, or versus this area of field is not producing anything, right? So then they will try to figure out what would be the thing, like, then they can probably figure out, well, I've seen the machine usually breaks down here. Oh, why is that? Is there like a lot of rocks in there? Is there a ditch in there? So all these kind of models or data scientists, they work on trying to figure out what might be wrong, and they can help the customers, like once they figure out like what's going on, they can go back and talk to the customers and see like, hey, this might be happening, this is how you can kind of increase your productivity. And this again also gives some analytical views of how much harvesting I did in particular area, this field versus that field, and you can get all these analytics, and it's actually used for some government reports as well. So this creates very nice reports, like in this field, this is what I did, this is what I planted, this is what I the fertilizer that I applied, and then this is what I got out of it, that sort of stuff. So all of this happens because of the data platform that processes all of this information. Uh, and then toward the ends, I'd like to talk about, like, just want to conclude by saying that precision agriculture is more than just an equipment, right? As you have seen, you can have a bigger, faster, and stronger equipment, but with introducing the technology like IoT and data science and a lot of other things is where we kind of get to the state of precision agriculture, right? And hopefully this presentation helped you understand how precision farming helps to grow more with limited resources, and how John Deere's IoT and data platform works, right? What I have touched is like a scratch. I will just scratch the surface, as you can see, because the technology stack is extremely complex, right? And it's always evolving, right? So, like, for example, there was a question about, like, what are we doing for India, right? What I would say is, like, yeah, there are some things happening within India, but I hope that this talk has actually inspired you guys to kind of become a technologist, use your computer science, and probably someday you'll work for John Deere and try to help this, solve this problem for our farmers as well. John Deere is doing. There are some initiatives that are happening trying to bring all of this into a lower cost model, right? Maybe not all these features, but kind of a smaller set of features with a smaller cost devices. But at the end of the day, students like you, engineers like you, who would eventually gonna make all this, this realize this dream. So, I'm really excited. I'm really thankful for this opportunity, and I can take any questions if you guys have any.
Sir, to use these machines, the farmers should be educated, right? Because in India, that's a big problem. Most of the farmers are illiterate.
Mhm. Very good. Very great point. So you're absolutely right. And these machines are really complex. Right? It's not easy. I've driven some of these machines, but the thing that they are doing is, so the complexity is hidden in the core. They are kind of putting some layers on top of it, right? So they are making more visually understandable. So instead of you have to press this lever, this button, this, it's not like an airplane, but it's more of their displays. Like, they have this big display. So, like, here, if you see, when I'm planting this image, if you see here, it's clearly telling there's something wrong in here, right? You don't have to look at the data and all that. You see, like, something is wrong going on here. I can stop the planter and go back. And what we are working on is the next generation of equipment. That means fully autonomous. So we recently released an equipment, a till equipment, basically, that kind of prepares the ground, which is fully automated. So farmer doesn't have to do anything. He just takes the tractor, just parks it at the edge of the farm, and then just sits back and relax. The tractor will wake up. It will put the implement in ground, and it will do the whole tillage operation without any intervention. User will have his mobile phone or a tablet, and where he can just see what's happening. And once the job is done, it will just tell the farmer, like, hey, I'm done, and farmer will go and bring the tractor back. Again, it's probably in very preliminary stage. This year we are releasing it to around 50 customers, and they are renting this technology. But again, as I said, the more and more people start using this, the technology is going to get cheaper and cheaper, right? So down the line, I really hope that this kind of technology comes, and where farmer just sits in his house, the tractor goes, does the thing, and comes back. Or combine goes, does its thing, come back. All farmer has to do is just kind of load them up, and it will do that. So these are the things that, at least from the company side, we are trying to do to make it fully autonomous. And user or the farmer doesn't have to really know about a lot of these things. But till we get there, we are kind of trying to achieve that by giving a very nice user, a simple user experience. So it's it supports multiple languages. The system supports multiple languages. So in India, it support Hindi or any regional language. And we are trying to put more visual markers so that it's easy for someone to really understand on what's going on. Does that help?
Yes, sir. Yes, sir. Basically, for India, it will take time for the
It will
farmers
take
to get comfortable with the technology.
Well, yeah, and we need guys like you, right? We need engineers like you who really understand and kind of slowly will be able to realize that dream. So
Yes, sir.
absolutely, yeah. The main thing is bringing the cost down and kind of using the technology to do a lot of these things so that farmer really don't have to worry about that. All he has to do is like, if you want to sit in the tractor and then let the tractor do it. Because like example, auto track is a great example for that, right? Auto track is where, you just don't do anything. You just sit in the tractor, and just let the tractor do the work. Yeah. But in case of Jupiter, the newest technology that we are bringing, you don't even have to sit in the tractor. The tractor will do everything for you. But these are some of the things that we are trying to make sure that farmers don't get overwhelmed with this kind of technology. Good question.
Thank you, sir.
You're welcome. Any other questions? Well, if not, that's all I had for today. I hope you guys liked it. And again, feel free to reach out to me if you have any questions.
Thank you so much, sir, for such an informative session. Now, I would like to invite Diksha Chagani, Chairperson AITR ACM Women Chapter, to end the session with a short vote of thanks.
Thank you, Drishti. It's such an honor to get the opportunity to thank you all. On behalf of the AITR ACM student chapter, I, Diksha Chagani, would like to express my gratitude to all esteemed delegates of the webinar for their presence and contribution to make this webinar a great success. I extend my gratitude to our guest speaker, Mr. Lokesh Bhatter, Engineering Manager in Data Platform Organization within John Deere, to grace the event with his talks about IoT and precision in agriculture. Thank you, sir, for enlightening us with your words. I would also like to mention that even after the time gap between India and US, sir has managed to join us here. Thank you so much, sir. I would like to extend my gratitude to AITR management. A heartfelt thanks to the respected director, Dr. S.C. Sharma, sir, AITR. A special thanks to respected Dr. Kamal Kumar Sethi, sir, head of Computer Science Department, AITR, for providing immense support to make the event successful. I would also like to extend my gratitude to Mrs. Priyanka Jangre, ma'am, faculty advisor of AITR ACM Women's Cell, for systematizing a webinar on such a trending subject. Heartily thanks to Mr. Narendra Pal Singh Rathore, sir, AITR ACM faculty advisor, team of AITR ACM chapter, and AITR ACM Women's chapter for organizing the event. Also, a special thanks to all the participants for making this session a success through their active participation. Thank you, everyone, once again for making it a great event.